the volume of world shipping. To frequently amended schedules and orders has been added ever more time at anchor, waiting for berths to become free, demanding ever more care from masters, crews and pilots concerned for the safety of their vessels. For the past 20 years have seen over 1,000 anchor-related incidents, mainly among the largest vessels. Anchors have been let go in the wrong place, at the wrong time, in the wrong way. Whole cables have been lost and windlasses shattered. The cost in expenditure, careers and equipment is immense and poses the awkward question: do those responsible properly understand the basic design principles and limitations of their anchoring equipment? In addressing this question head-on, and since most reported incidents have been aboard large vessels, our program looks closely at two separate anchorings aboard the same bulk carrier plying between Europe and North America. In illustrating here what's best in anchoring practice, we shall also point out the pitfalls for ships of all sizes. Our first destination and anchorage is in Sept-Îles on Canada's St. Lawrence River. Our second, different master, different crew, same ship, will be Rotterdam in Holland. To anchor in either location, a master will aim to bring his ship over the precise position he has chosen within the area assigned him by the port authorities, making it crucial that he find out in advance everything he can about his anchoring ground. For the busy Maas approach to Rotterdam, the chart shows the extent of the anchorage, available depth, and the nature of the seabed. The master will also need to know the latest local weather forecast and the prevailing tides and currents, as well as any subsea pipelines, cables, wrecks, reefs or shoals in the vicinity, and where precisely they are located. The bridge team must now plan how to take the way off their ship while plotting a course through others already at anchor. Finally, the master must work out how many shackles he will need to bring his ship up safely and in the correct position. All of which must now be carefully communicated to both bridge and deck crews.
Well, before engaging the gear, we'll inform the bridge, and then we can start lowering. Okay?
We will start slowing down at the entrance, at the harbour limits of Sept-Îles. We hope to have reduced to about 4 or 5 knots by the time we approach pilot station. The tide is expected to be ebbing at that time, and also we will see the general direction of the wind and in which direction the other ships at anchorage are laying. We hope to work ourselves into the same heading as the other vessels. Once we are in our chosen position, we will get the forward anchor party to start lowering the anchor on power. The depths are about 25 to 28 meters, so we will lower the anchor under power to approximately 1 shackle on deck, which is about 28 meters. Then we will change the anchor onto the brake, take out the gearing, and we will lower the final part of the anchor on the brake because I would not like to keep additional pressure on the gearing. We will still come to a stop and come to a minimum speed so that we can gradually, slowly lay out the cable on the bottom.
It is vital for a ship's master and crew to have a thorough understanding of their anchoring equipment, starting with the anchor itself. Being of cast metal, this is brittle and quite able to shatter on rock, making the safest seabed a soft one, into which an anchor's flukes can bite firmly and remain embedded until weighed. The AC-14 is the most widely used anchor on large ships and VLCCs today, holding up to 15 times its own weight. To the anchor's strength is added the effect of the weight of however many shackles of cable are used. Combined, the two provide the system's total mooring power. Most ships will let go one anchor only, from which the lashings must be cleared away, the stoppers checked, and the spurling pipes cleared on approaching the anchorage. Good seamanship, though, dictates that the second anchor also be cleared against emergency, but leaving the stopper on. Controlling both anchor and cable, the windlass may appear robust with its hydraulic, electric or steam motor, its drive shaft, clutch, brake, gearing system, the gypsy that guides and controls the cable, and finally both stopper and anchor lashings. The fact is, though, that it's a relatively delicate piece of equipment. Under classification rules, the windlass is designed to control and stop the anchor chain only, in motion up and down. It is certainly not designed to support the mass of a 200,000-ton ship. Indeed, even the walking out of cable, out of the vertical, will impose an excess load, if not immediately slacked back. Yet excess loads continue to be imposed, and to lead, over time, to metal fatigue and to metal shavings entering the hydraulics, where they can cause serious and mostly unseen damage. Until too late. Of course, on the vast majority of ships, the windlass is routinely maintained between anchorings, often at the same time as weighing anchor. Greasing through the nipples and on all external moving parts both lubricates and prevents rusting. Filters must also be routinely checked and cleaned, and, vitally, brake linings and screws checked for wear. So far, all the master's plans have been drawn up at sea. At Sept-Îles, the site of how other ships lie at anchor may lead to modifications.
Position. As soon as I have dropped my way off, I will tell you to start lowering.
Sir, copy that. I will just try.
Okay, so now we've finished priming the pump, and the pump is running now.
And at every anchorage without exception, repeated checks must be made on the windlass and other anchoring gear.
We'll check these clock couplings.
Foundations must be inspected and hydraulic pumps tested. The clutch must be engaged and secured.
As soon as I have dropped my way off, I will tell you to start lowering.
Checks, too, must be made on communications between forecastle and bridge, especially on the largest ships, where the sheer distance between the two might otherwise be a problem.
325.
As the ship approaches her anchorage, her master will have been for some time slowly reducing her speed from cruising to approximately 5 knots.
Okay, we have about 1.5 miles to go, and we're already coming down on our speed. You can put the anchor in gear and slowly lower to 1 meter above water level.
Sir will lower the anchor 1 meter above the water level.
With the windlass in gear, the cable stopper is removed and the brake released.
Remove the brakes and lower the anchor to about 1 meter above the water level now.
Given the 25-meter depth here, it is quite normal to approach the anchoring ground with the anchor walked back to just above the water. Much deeper, perhaps 50 meters, and it is usually walked back just above the seabed, reducing any risk of its fracturing on impact should it fall on rock. Safe fore and aft anchoring depends on first-rate ship and cable handling. It demands precision timing and accurate observation from all involved as, metre by metre, the ship approaches her anchoring ground.
Stop engines.
Stop engines.
Now, with the brake fully on, the windlass can be taken out of gear.
Let go, and you pay out now to 3 shackles in the water first, and check the cable at 3 shackles.
Okay, sir. We'll check the cable at 3 shackles.
From the moment the anchor is let go, precision, timing and communication are critical if excess loads are to be avoided on the anchoring gear.
Yes, sir. Now 3 just outside the hosepipe, and cable is up and down.
Okay, when the cable starts growing forward, then you pay out to 5 in the water.
Yes, sir. Anchor lowered to 5 in the water, cable up and down.
Tighten the brake and watch the cable. You can put it in gear and walk back to 7 on deck.
Okay, sir. 7 on deck. We'll go back to 7 on deck.
Okay, thank you.
And never is communication more important than when walking back with the gear engaged. Here, any failure to match sternway with the speed at which the cable is paid out could set the whole ship's mass against the windlass. Finally, with all the cable he intends to use now out on the seabed, the master calls for the stopper to go on, and waits for the mooring power of both anchor and cable to bring his ship gently up.
Good morning again, Bergen Nord. We have now anchored in the bay.
Safe fore and aft anchoring depends, first, on the vessel being stopped dead over its anchoring ground, and second, on the avoidance of any excess load on the windlass arising from its being out of the vertical while the vessel is under sternway.
Should anybody make a mistake in the speed over the ground when the anchor is let go in the fore and aft direction, the windlass will also have to counteract the entire displacement or the weight of the vessel, that the windlass is certainly not designed for taking the whole mass of the vessel, even a part of the mass of the vessel.
Against 1,000 incidents arising mainly on the very largest vessels, one has, of course, to set the tens of thousands of times they have anchored safely. There is, however, an alternative method of anchoring dating back to the days of sail. A method that harnesses wind and current rather than its engines to take the way off a ship. A method we are about to see demonstrated in the busy anchorage beside the Mars approach to Rotterdam. Throughout the initial approach, on-board checks and preparations for both fore and aft and sideways anchoring methods will be identical. Only perhaps in its approach downwind or downtide and in its speed might the sideways method be seen as different.
The moment you turn a vessel around for the sideways method, the vessel will come to stop naturally because the headway is taken off in the turn itself.
The key word here is naturally. As the vessel nears her anchoring ground, and depending on which anchor is to be let go, her master initiates a swing to port or starboard.
Forward?
Yes, sir.
Yeah, I'll be swinging to starboard now, Anand.
Okay, sir.
115, sir.
115.
Starboard anchor is in gear, still on brake and bow stopper.
Yeah, I'll let you know when to remove the bow stopper. Just stand by. We are coming up to more or less stop in the lateral direction. So just take out the bow stopper and get her to the water level, the anchor to the water level, starboard anchor. Just walk back to the water level.
Roger, sir. We'll take off the bow stopper and walk her back to the water level.
Yep.
So starboard anchor lower to the water level.
Starboard anchor to the water level. Thank you.
Yeah, can you walk her back to 1 on the windlass forward?
1 on the windlass, sir.
On full rudder, aided by wind and sea, the vessel turns slowly through 135 degrees. As the turn increases, all forward movement ceases.
2057205.
The starboard anchor can safely be let go.
Yeah, you can let go the starboard anchor. We have a drift of about 1.2 knots or so.
Upwind or uptide now, assisted by short bursts of power where needed, the ship drifts gently sideways and astern, paying out cable in a single controlled movement.
355. Yeah, just put the bow stopper and lock it and put the pin.
By the time she is brought up, the cable will lead out in a gentle curve on her beam, while the vessel turns quietly into the weather.
Mars approach, Mars approach, Mars approach. Bergenord, Bergenord, Bergenord. Mars approach, this is the Bergenord. Good evening to you. We are anchored here at Delta Whiskey 2 anchorage. The anchoring time was 2240 local time.
Once at anchor, clear telltales should be set up on the cable and close watches kept for signs of slipping or anchor dragging. Signs such as tension on the cable, vibration in the vessel, movement in respect of others at anchor, or distortions on the course recorder. Once an anchor starts to drag, it is difficult to stop, while all the time the danger to other shipping grows, leaving only one option: weigh anchor, move the ship, and start again.
We are at anchor. This is the position we have marked on the anchor.
The officer of the watch is responsible for the safety and security of both ship and crew. To these, once at anchor, is now added the general safety of other ships in his vicinity. Each officer taking over must be reminded of standing orders and thoroughly briefed on any incident that may have arisen during the previous watch. Alone and in charge now, a dragging anchor, a tidal surge, a sudden change of weather, would all be potential hazards to which he must instantly alert the master. The procedure for weighing anchor is similar to that of letting go, only in reverse. Telltales are removed from the cable. Windlass foundations and systems are once again checked and tested. On the master's order, finally, the bow stopper is removed.
Bridge forward, can we start heaving?
Yeah, if you're ready, you may start heaving.
Shackle by shackle, at 5 centimeters per second, the cable is raised. Carefully taking the load off her cable and keeping it vertical, the ship's engines nudge her slowly forward to the point where the anchor was first let go. Set in the hawse pipe, powerful hoses wash off mud and seabed debris. While, with the windlass in motion, the crew have the perfect opportunity to apply protective grease against the long sea voyage back to Canada. Ships weighing anchor should keep, too, a close lookout for other vessels moving in their direction, and who may, in spite of VTS warnings, consider them still at anchor.
Yes, motor vessel Hooturn, this is the Bergen Nord. I believe you're the one crossing the Delta Whiskey 2 anchorage. I'm the vessel anchored on your starboard bow. I'm picking up my anchor. I will be underway shortly. So.
At last, the bow stopper and its pin can be replaced, the brake set, the anchor lashing and spurling plates reset for passage. Vital safeguards that, neglected or carelessly done, have led in the past to damaged hulls and to anchors lost in stormy seas. Safe anchoring is about being careful and respecting both the forces with which you are dealing and the capabilities of the equipment you are using. It requires practice and close teamwork. In our program, we have illustrated best practice for safe anchoring. We have also highlighted some of the major pitfalls. To reduce the number of 1,000 anchor-related incidents over the next 20 years, however, all seafarers will need a greater understanding than shown in the past of their anchoring equipment and of its use in practice. Only then will they be able, with confidence, to anchor safely.